Hello, and welcome back to Data Visualization Fundamentals here at Observable. This is part 4 of this course, and we should have realized earlier that we should make some sort of chart around this. I keep thinking maybe we should make some pie charts about how far we are into this course, but we are at 60% now, and at the at the end of today, we'll be at 80%. And then we have one more. Last 20% will be next week on Tuesday. Which I believe is actually the first day of spring. So there you go. There's your little factoid for today. So today we'll talk about transformations. I might also bring back a couple things I wanted to talk about last time in comparisons, but for the most part, I'm going to stick to today's plan about transformations of data to do, for data visualization purposes. And also, very briefly, I wanted to talk about the assignment, but I might just wait for this to do this a little bit longer because people are still joining. So I'm going to give folks a bit more time. I will say though that we don't have it available quite yet, but it will be on Tuesday. But and you will have enough time. We'll give you 2 weeks to work on it. It's not going to take you that long. So you will see more on that next week on Tuesday. But I'll give you a quick preview in a bit. And I see a lot of people joining here from all over the world, so welcome. Glad that you were able to make it, especially Europeans, where it's now an hour different than before. So sorry about that. The US is a bit ahead of the rest of the world with the switch to daylight savings time. So today, we will be talking about transformations. And what that means is essentially the question of like, what does our data look like when we're not looking at the row level? So in the past, we've mostly either pretended that we're looking at every single record, or we've actually looked at every single record. So for example, my standard example here of the bar chart uses this alphabet data set. And so there are these 26 bars that show you the frequency of each of those letters, and that's actually the data that we have. So if I look at the actual data set, and actually hit the correct button here. Why is this not doing what I'm expecting it to do? There you go. So now we have this array of 26 objects. I can show you the entire thing because it's not that many. And each of them has exactly those two values. It has a letter and a frequency, and that's it. That's our entire data set. Actually, maybe I'll show you this as a table real quick too. Table. I'm using our old school table here. So this is the data table, and we have exactly these two columns here. We have the letter and we have the frequency, and that's all we have. And we have exactly 26 of those. And so showing them in bars, in a bar chart, means that we draw one bar for each record. And so that's of course this is coming from a much larger data set, but there was some kind of system that went through this and counted all of those letters and gave us these values. But what we end up with is a very small number of records. But what if that isn't the case? What if we have a lot of data? And what if we have a lot of data points, but we don't actually want to see them all? So my example for this is our Olympians. For some reason I can't time today. Olympians, there you go. So the Olympians data set, okay, maybe I'll zoom in here a little bit. There we go. Consists of almost 12,000 records here, right? So this is 11,538. It's a lot of people in this data set. And we could look at all of them, and I've shown you a few examples of like scatter plots and stuff that showed more of the data. Actually, I showed you most of the cars where we have a few hundred, but you could do that with the Olympians. But you don't usually want to see every single data value in this case, because you're usually mostly interested in more kind of overall views of the data. And this is even more true when you're looking at tens of thousands, hundreds of thousands, millions of records, as you might be doing if you're looking at business data. You might be looking at lots of transactions. You might be looking at lots of customers, and you're trying to figure out what do they have in common, things like that. So very often what we want to do is want to aggregate the data. And aggregation is essentially just a matter of figuring out what do we want to see about the data and what does it mean for our aggregation operation. So in my standard bar chart example, which I will deconstruct here a little bit, we do that with this group function. In fact, I'm going to take that out first and show you what's actually happening here. So I'm going to take, let's see, this out here, and then I need to get rid of bracket here. So what I'm going to do here is we're going to create this bar chart that will be showing us our athletes by nationality. So I'm breaking this down by nationality. That's going to be on my vertical axis, on my y-axis. So let me show you what the chart actually looks like before I show you what I'm trying to do here. So again, I'm unable to type today. That's what I wanted. So you've seen this before. This is the bar chart of the number of athletes from the different countries in our data set. So this shows us how many people we have from the US, from Brazil, Germany, and so on. And what I'm trying to do here is build the same chart, but do it sort of from the bottom up by not looking at what this already does. So we'll get rid of this. And instead, what I'm doing here is I'm going to say, why don't we count the number of records of people by assigning them all the same value. And what I'm going to do here is I'm using a little function here, if I'm able to do this correctly, which I'm not. Okay, I'm missing this here. All right. So what I've done here, I'm going to zoom into this part because I want to show you that what this is doing here. So this function, this expression here says that the x value, I'm mapping something here, which is a function. So I've shown this very briefly before. This is what's called an arrow function in JavaScript. And the way this works is that there's an input on the left, and in this case it's empty. So I'm just saying, well, I don't care what you're passing into this function. And then the other side returns a value. And in this case, it always returns 1. So for every record, for every person in our data set, for every row in this table, we're going to get the number 1. And what plot is going to do when it's using bars, it's going to stack those bars. And that's why you see this Mori pattern here. So if I zoom in here, I'm going to see if I can get far enough so I can actually see this. It doesn't actually go quite as far as I was hoping to because the screen here is a bit smaller. But the idea is that as I'm zooming, actually, let me try this differently. Maybe this is going to look different if I do. Yeah, this is the kind of zoom I'm looking for. So if I zoom in here, that's as far as I can go. You might see that, I hope you can see that they're actually little slivers, little individual bars that are all 1 pixel wide. And so what I've done here is I've taken every single record out of my almost 12,000, and I'm grouping them vertically into these countries, into the nationalities, and all the ones that are in the same nationality are now going to stack up to the right. And so that way I'm very laboriously constructing a bar chart here by simply stacking up lots and lots of individual little boxes. And this is, of course, a very stupid way to do this, but I think it's useful I hope it's useful to see how this works, because I'm creating a pile of objects basically. And that way I see the difference in the numbers, because just as you would stack, I don't know, like blocks, if you're playing with like wooden blocks or I don't know, toilet paper rolls. Sometimes I've seen people use that to represent data or whatever you want to stack. The same thing can of course be done by just adding those numbers or counting those values and just representing the total value. And that is what the group transform does. So again, this is the laborious way to just do this by hand, just to show you. But the way we actually do this, and I have to look at my cheat sheet here, is by using this group function. So the way it's done in plot is that I'm just going to copy this from my cheat sheet, which is basically just using the code from the from our example chart. I think if I do this and just move the sort, I'm still doing it wrong. Oh, because I need to put this in its own set of brackets. So what I'm doing here is that, and so now if I zoom in, you will see that there is no more moire pattern because these are all solid bars. And that is because I have, sorry, I'm going to zoom out and back in to make this better. Now what I've done is I've used a function. This is called group, and there's group X and group Y. And these just basically differ in what values they add, which channels they add up. And I'm telling it that I want it to count, and then what do I count? Well, we count the rows, but we break them down by nationality. So the group Y breaks down by nationality and then applies a function. In this case, it's the count. And so the count is basically just the simplest form of aggregation. And it's actually a very useful one. Very often you want to know how many of something there are, even if that's just part of your process, but it's always interesting to know how many individual sales did we have, how many customers do we have, how many of something do we have, how much, how many items do we have of different things. And so this is one way of counting, and it's the simplest. I call it the simplest because it doesn't depend on anything else. So in this case, all I'm doing is I'm counting the rows. I'm not asking what's the average value of this or that. I'm not asking something that depends on the second data dimension. This is simply a count of just the values that I have. And then in addition to the title here basically just says, show me that count as a tooltip. So I can now see the number. That's all the title means. And by the way, I just want to make one thing here. Hopefully this is useful and clear. One thing I want to show here real quick is that I don't have to sort. So the sort is kind of just there in this example, but I can also just, first of all, I can just take that out entirely. And then this is what we get. The sort does two things here. It sorts the values and it cuts it off at 10 total values, or maximum 10. If we had fewer, then we wouldn't see, obviously we wouldn't see 10. So this is now all the countries in our data set, unsorted. Unsorted, and then just shown in whatever the order is that plot decides here, which I think is just sorting the nationality, the vertical value. But I can also bring this back and just remove the limit, and then we'll still have them sorted. So we still have the US here as the most number of athletes in this data set, and the Brazil, Germany, and so on. But we'll have all of them. So just to show you what these other parts of this is, if this code here are doing, and I can limit it to 10, I can limit it to 20, whatever I want to do. But I can show more of that data here as well. This doesn't have anything to do with aggregation, but I just wanted to show that because I keep reusing this example, and I wanted to make sure that there is a reason for this. All right, so there's a question here about plot. Can plot group Y take a function as a value? Yes, absolutely. So the almost everything, I don't want to show this because I haven't prepared it, but almost everything that you see in plot that is an assignment like this can take a function, and then it just gets the values passed in, and you just, I don't know exactly what they look like, so that's why I don't want to try this like ad hoc here. But yeah, you can totally give it functions. The same is true as you saw me do earlier, and I've already gotten rid of this, but anything, all of these mappings here where I have a name of a column, those are basically just convenience functions. And actually, let me show you this real quick, even though it's a bit of an aside, but I wanted to show you this. So the question is a really good one about how plot works, and also how I think Observable thinks about data access, and how you usually do this or how you often do this in JavaScript. Of course, every library, everything is different. So I call this a convenience method here because I can just give it a string, or I can give it a function. So what actually happens here is that I'm getting a value. I always call this D. I don't know why, but I can call this whatever I want. So this is my input. Then I have my arrow, and then I just say d.nationality. And that should give me the exact same bar, right? So this doesn't, it's not very exciting because I'm doing the same thing. If I do this by sport instead, So now I'm saying d.sport, I'm going to get the breakdown by sports. So what plot does is it goes through all the rows, and whenever it has to figure out what to do with that row as it sorts them into the categories for the vertical axis, it calls my function, and it calls my function with that row, the row being the object. So this is this kind of object, and then that has properties, and I can access any of those properties by just using this dot notation. Or I can just make this more convenient and just say sport, and then plot does that for me. It basically creates that accessor function for me. Yeah, good question. I just don't know exactly how, because this is what's called a reducer, because it has to reduce the whole set of records into a single value or a small number of values. So I don't want to do this right now because I haven't prepared this, so I don't know how this works exactly. All right, so next point on my agenda here. Counting. So counting is again the simplest version, really. But then there are obviously other ways of aggregation. And so another one is what's called binning. And I just have a little thing prepared here to show you that. And binning creates what's called a histogram. So this was already mentioned by folks, I think, last time in the questions, I believe. Maybe I'm not sure if I actually got to that question. But binning is a very useful thing to do when you have lots of values and you want to understand the distribution of those values. So what I'm doing here is I have a chart that is that's using the dot mark, the dot function here, to draw a simple chart here of all my almost 12,000 athletes by weight. And since I got shamed last time for not having the units on the axis, I added this here. So this is weights in kilograms, just to be clear, because last time I was talking about temperatures and those were Fahrenheit. So this time we're going with metric. But anyway, so what this does is it shows the weight here on the x-axis, and it draws a little circle for each athlete. And I could also fill that, I guess. But that actually makes it harder to see. Well, actually, I'm not sure if it makes it harder to see in this case. But because what I'm trying to show here is that I turned down the opacity fairly low. So if there's a single dot somewhere, then it's fairly pale, but it gets darker as there are more that are overlaid. And what you can see is that there are lots of them. And of course, I'm drawing 12,000 dots here, so you cannot see all of them. So what I can do instead, and again, this is my laborious way of doing this first, is I can, well, in this case, I'm going to actually use a function that is called dodge that will, what I will do is when there are multiple dots in the same spot, it will try to push them apart. And what happens here is, as you can see, is that this takes up a lot of space because there are a lot of athletes. So I'm gonna give this a bit more space, and then I think I had 1,200 there. This isn't actually going to fit on the screen at all, but because I reduced the radius. So let me make this a little bit smaller, and then we'll turn these all back down here. So oh yeah, this kind of works. It looks a bit different than in my write-up, which probably has more to do with the size of my window than anything. But I know what the difference is. So because I was using the stroke instead of the fill. So what has happened now is that we're drawing these 12,000 athletes, and we're drawing them individually as individual dots. So we have 12,000 dots, and I'm using the dodge function here. There are different ways certainly of doing this, but I'm basically so you're seeing every single record here, but just as a little dot, and they're stacking up because when the values are the same, and these are full kilograms, I guess. So we're seeing some quantization here that when they have the same value, they get pushed apart. and vertically pushed apart. That's what the dodge y does. And so now, because I'm well, have a lot of those values, I'm creating these huge stacks here. So you can see that this ends up actually taking up more space even than I even gave it. But you can see that there's a huge range, and you can see all these little spikes. So now you can see a distribution. Oh, I've already gotten rid of the other one. But earlier you could see that there were more values in the middle here, but it wasn't clear how many. And so now you can actually see that. We can also see, well, actually, this is easier to see here than in the other example that I'll get to in a second, or the other way of doing this, is that there's apparently quantization. Well, quantization, of course, there is, because we can tell that there are only whole numbers in between here, because it looks like there's 10 in between every 10 on the scale. But it also looks like there are a lot more values where there's multiples of 10, or multiples of 5 and 10, I guess. So you can see some interesting patterns like that here. And so this is actually a useful representation. It's not the way you would usually do it. Again, this is the stupid and laborious way of doing this. This is really what would be called a B-swarm plot, when you have a small number of records and the values are continuous, not as quantized as here. It's actually quite useful to do this kind of chart. But what I'm actually trying to get to is, again, a different kind of aggregation, or, well, it is an aggregation, I guess, a transformation, certainly. That is a called binning. So this transformation here, using what's called this function called binx, does essentially the same thing that I just showed you here. So it takes the values on the horizontal. Well, it takes the horizontal axis, breaks it up into individual bins, or like buckets, and then and those are ranges on the axis. So it picks some number and then takes the total range of values and slices that up into these individual buckets, and then it goes through all the values and looks at which bin do they belong to. So if there is a bin that goes from 80 to 82, then the number 81.5 would be in there. Or if it's like the number 64, and there's a bin going from 63 to 65, it would fall into that. So you get a small number of bins here, and that gives you and so this is called a histogram when you draw it like this, which is kind of a bar chart, but it's also kind of not, because the bar chart, as I was trying to show and have harped on several times, is that the bar chart is very much about categorical values. So I'm not sure if it really should be called a bar chart, even though obviously these are bars that you're seeing here. But the thing about binning and about bars is that it's really important to realize that there is a variable here that you can change, which is the number of bins. So to show you that, I can add a little control here. Lets me change the number of bins, and then I can add this down here. Sorry about that. Using a field called thresholds, and I'm going to give it a number of bins. This is called threshold. Well, actually, I'll get to that. But so what I can do here is I can now change how many bins I want in my histogram. And I have this in the write-up too. You can play with that later. So what I can do here is I can change roughly the number of bins. Plot doesn't like all these numbers, but it will go along with most of them. So if I have 100 values, you can see that this is the number of bins I get, which is not actually 100, but it's sort of like a close value to that. And we can see something that looks a bit like this. So I now have essentially every single value represented, and you can see these little spikes. So this is what real data looks like. This is the kind of spikiness that you would actually see. But now you can ask, well, do I want to see all those spikes, or do I want to see the overall distribution? And so in that case, it might be more useful to go down here somewhere where you get this kind of normal-ish skewed kind of distribution that is not much smoother than this, but this is more like what you kind of expect from a statistically kind of smooth distribution. And of course, you can overdo this. Over here, you could just like go actually down to 2 values, which is of course very extreme. But you can see that there's a vast difference here depending on what number of bins I choose. And as I'm hoping to show here, more isn't necessarily better, because more gives you more of that noise, but it can also show you things that might be odd. Like, why is this bar so low? There may be a reason for that. Maybe there's something wrong here, or there might be something in your data process that might be causing this, or something else. But again, the point of the demonstration here is mostly to show you that this is a transformation here that's called bin, and that does this binning, and it does it in this case by counting again. So this is why I said that counting is a very useful transformation, and it uses the weight here as the axis that it then slices up into the number of bins. And I'm not going to go into the details here. When you don't give it a number of bins, then Plot chooses the thresholds using a heuristic that I don't know the details of, and there are a variety of different ways of choosing those bins. So there are automated ways that tend to work well, but based on certain criteria. But you can also just choose your own, and it's called thresholds here because you could also pass in an array of exact thresholds that you want, not just a number. So if I pass in the number, then I just get that. Then I get the sort of like approximate number of bins. But I could pass in exact values of where I want my slices to go, and then I could just choose whatever I want. All right, I'm just looking at the questions here. Yeah, so this is a two-part question here, I guess. What is the best way to choose the number of bins in the histogram? And then, so we'll choose based on our own experience. And that's what I'm trying to get at here, yes. So there are heuristics for doing this. There is no single answer to this, because as I was trying to say earlier, it depends on what you're after. In this case, it happens that we could actually do this. There's a maximum value of bins, which is just all these values here, because we only get values at whole kilograms. The number of possible values here is limited, so we could actually have every single value, which is basically what you're seeing here, which is actually exactly what you're seeing here, I think. But again, the question is, do you want all this noise, or are you looking for the overall distribution and don't care about the noise, and then you want a smaller number? So there are reasons for both, and for either. It really depends on what you're after. Back to this discussion we had last time, and that then this continued on Slack a little bit about, like, well, are you biasing the data? And I say, yes, you are. You're always. There is no way around that, because whatever you choose here, somebody can always argue that you should have chosen something else. So there is that's, and I hope I don't know, last time I was quipping a little bit about the natural intelligence playing a role here. There is a part of you that goes into this. Creating charts is not something that's just done by machines, and there are hard and fast, precise rules for this. It's just not how this works. It really depends on what you're after. If you want to see all these little things and you want to ask, well, why are all these weird multiples here with these big spikes? That's a valid question to ask, and that's something you might want to investigate. But then again, you might not care. You might want to see the distribution. If this is the age distribution of our customers, then I don't care that I get these multiples, because they're probably just noise in the data. So again, noise can be interesting, but it can also just be just noise. And then I'm going to look at this and say, well, this is what I care about, because my age distribution skews younger, which might be a good thing, might be a bad thing, depending on what I'm after. So there are different reasons why one or the other might be more interesting. So yeah, but it's a good question. I think this is something I'm trying to explain without making too much, without making it sound too much like it's all subjective, because there are certainly some sort of rules, and I keep making these finger quotes here because there are rules, but very often there are lots and lots of exceptions to those rules. And so there is a large amount of judgment that you have to use to make good charts, because it's just not always clear why you're making it. Well, or I should say that what you're doing, the kind of chart you're creating, depends very much on what you're after. And so there is the intent behind the chart is another very important part. All right, so let me look at what else I want to cover today. So I want to, yeah, okay. So the another kind of aggregation and transforming is stacking. And you've already seen this a little bit because I took I did tried to do this earlier where I stacked all the same values and then created this chart that kind of counted the values by just stacking them all up. But stacking bars is also a common thing people do, and I want to essentially tell you that this is actually not a good idea. So, and I hope to convince you with my little example here. I'm gonna go with a bar chart here again. I think, no, I'm gonna copy this from my write-up, just because it's essentially the same chart which you've seen 1,000 times before, which is the Olympians by country, but I'm going to do this vertically instead of horizontally, just because I think it makes it a bit easier to read. Here I have the number of Olympic athletes by country, just like as you've seen before. But this time it's vertical bars rather than horizontal bars, so technically columns. And so we have the nationality here, we have the count, and now we could ask, well, what else can we add here? What else could we show here? We could perhaps show the sport, right? So we could add a fill for the sport to see how many of each sport we have. And that actually makes a stacked bar chart by default. And this is one of those things where plot does work for you because it knows that when you have bars and you add another way of breaking them down, that it should stack them. And there are other ways of doing this. And actually, I'm going to show you a thing that I wanted to talk about last time in a moment. That is the you can also make group charts. And I'm going to add a simple legend here. True. This is not a good chart for many reasons. One of them, and I'm not actually going to talk about color really pretty much at all, but I hope you can see that there are too many categories here. So the colors have to get reused, which is one of the problems with having too many categories. But also, if you look at a specific sport here, like this green one here, I think is, actually I should be able to add a title, I think here. Not like this, more like this, sport. Now, as I move over here, so hockey here, let's go with hockey. The green here, if you just look at this green bar, actually no, let's start at the blue here. So the bottom blue bars, of course, we can still compare very easily because they're at the bottom. So aquatics, which happens to be blue, so that works, is easy to compare because it all sits on the same baseline. So all these bars start from the same horizontal line, essentially. So they're easy to compare. They work just like any other bar chart. But as you go higher up, let's go with this one because this is much easier to compare, I think, or to see. Athletics here in this red color, that because now these sit on top of these other bars, aquatics and something else, archery, and now these bars are much harder to compare because they are no longer aligned. So if you want to compare this one to that one, for example, it's going to be much harder because they don't start at the same point. And especially when they're further apart, like this one and this one, it really gets very difficult to compare them. So stacking is something that people like to do, but when sorry, somebody just said, well, if I remove the limit, then we'll get ultimate insanity, which is a good point. But the point is that so we get this crazy chart. Actually, this is a good idea. Yeah, thank you for that. This kind of chart is not uncommon. You see this quite a bit. People just add way too much stuff into their charts, and even if the limit is just like 25 or something, it's just too much. And so I think it's really important here. Again, this is intent. What are you trying to show? And this is just trying to show all the data. But by showing all the data, you're not actually helping people understand it, because this is just chaos. Even if it's just 10, it's going to be too many. So it's just too many values, and the stacking seems to help, but it really doesn't, because you just essentially all you can do is try to you can compare the total bar height. So this is essentially doing the same thing I did earlier with my individual values, where all of them were 1. But in this case, of course, they're adding up to the total number. So I'm essentially getting just overly colorful, very busy bars, and I can see the total size of the bar, the total height of the bar, but I can't really read this as a as individual pieces here. So if I want to look at rowing, it's just going to be impossible. Having said that, it can work in some cases. So if instead of breaking this down by sport, I use something that has fewer values, like I can go with sex here, then that makes a lot more sense, because I can reasonably compare to a small number of values. And I'm not trying to advocate this chart as being a good chart, but I'm just saying it's possible. It's more reasonable than when you have too many values. So stacking is a bit of a mixed idea, where in many cases, I would say most cases, it's probably a bad idea, but in some cases it can work. And it's also possible you could resort perhaps the vertical axis, and then that way you get a better sense of what's happening there. Okay, and so here, sorry, I'm just looking at the comments. There are a few questions here about documentation. Somebody's asking about whether there will be a book about plot. I have no idea. That is a very good idea. I will talk to Mike about that. We probably should write one. But there is the plot documentation. I'm not linking that from every single notebook here, but I should probably do that. But there is pretty extensive documentation. And also there's a question here. I started reading the plot docs. Do you recommend reading specific topics first? Or should I just go topic by topic? I'm not sure what the difference is, honestly, but the plot documentation has a ton of examples. In fact, let me show you the plot documentation real quick. I might even have it open. Oh, there we go. It's almost as if I had prepared this, which I totally did not. But so this is the. So I'm just trying to get rid of the this here. So the plot documentation has a lot. So everything is listed up here as, well, it starts with marks and channels. I talked about marks, scales, and so on. Then there are the different marks, and then there are, further down here, transforms, which we're kind of talking about today. And then there are cheat sheets. And if you look at specific ones, I don't know, let's look at the bar mark, you will see a lot of examples there. So there are bar charts, as you've seen this one before. This is where I'm cribbing a lot of my examples. So and so there is right up here that walks you through a lot of things. And so the bars, sorting bars, different things you can do with bars. Actually, I wanted to show this the first time too, but then kind of ran out of time. So there are lots of examples here. And it gives you, I think, a good sense of what's possible. And it's also easy to get started by just taking bits and pieces from here. And then sometimes it's more documentation in the sense that, so for example, since we're talking about transforms today, the window transform, which I'll talk about in a second, has a number of options. And so then these options are listed here as well. So it tells you what those options are that you could put in there. It doesn't always do that. This is another list here of different options. So it doesn't always do that. Sometimes there is the link at the bottom that you need to look at. So lots and lots and lots and lots of examples. And then there's the API reference. So if you want to see every single possible thing you can do, then that's what you should look at. Sorry, I should probably remove the question here. So at the bottom here, you can see the link to the API reference. So then that gives you all the other information. I would not start with the API reference. I would start with the examples, what was the plot documentation. And this is easiest to find by just going to observablehq.com/plot. And then from there, there's a link to this collection. So this is a collection here of all of these values. And in fact, yeah, there we go. So and it's a collection called plot. Um, okay, so let me go back to this and get rid of my search window. This is just because I'm using the shortcuts, the Command Shift F here. How do they make the blue border and tooltip appear on hover? So this is a little trick that so this one here. This is a tooltip component that I'm importing. And I haven't talked about this much because I'm mostly hiding my appendix here, but there is a notebook that's called Plot Tooltip, and that wraps the plot library. So this is what I'm doing here. I'm importing plot from this notebook here, and that inserts that tooltip component. This is a workaround that we need right now. This won't be necessary in the future, but for now, this is a very simple workaround so that you get a nicer tooltip. So if I go back to my charts here, where else did I put that? I used it before, but I might have gotten rid of that. Yeah, so here, for example, so that's where you get that this tooltip from. The main advantage is that it's a bit the built-in tooltip works too, but this one is a bit easier to work with, and it's a bit more visible in charts. Did I? Yeah. Okay. Okay. Yeah, and so yeah, so you just see the yeah, and we just posted the links here to the plot documentation, and then also Angie just found that the import there as well. So this is the and you will see that also if you go to the write-up for today, you will see it at the bottom there as well. Pretty sure I'm using it there as well. So back to stacking very quickly. Another kind of stacking, and this is again just I'm just going to show you this very quick because I don't want to spend much time on it. But a different kind of stacking, and I've mentioned this before, I think, is this chart, which is a pie chart. So the pie chart, and don't worry about this. This is just basically using a function here that I also imported, calling the donut chart, called donut chart, which you can make it a donut or a pie by just changing the inner radius, which here is 0. I could change that to something else, and then I make it donut chart. But the point is that and you can see that this uses a different well, it's actually done in D3, so it's a different tooltip. But the point that I'm just trying to make here is that pie charts are a lot like stacked bar charts because the slices aren't aligned to at one point. So and that's part of what makes comparison so hard. So if I were to rotate this, I would make it easier to read individual values here. And that's actually why I think that's why people recommend that you start your pie chart at noon at vertical, so that the largest value is the easiest, especially if you have multiple. Then they're consistent and you can compare them to each other, which you shouldn't do, but people still do it. But it essentially works like a bar chart. So you can imagine this being the first part of the bar, and then the second and the third, and so you get this kind of stacking effect. And when you compare stacked bar charts to pie charts, people actually do worse on stacked bars. So this is just one thing, and then I'll stop talking about pie charts here and get to a few other things. So so in that sense, pie charts are just stacked bar charts, just in a different sort of transformation. Another thing that I wanted to show real quick here is stacking in area charts. So we haven't talked much about area charts, but areas are, well, they are a little bit problematic because they end up, well, I'll show you why they're problematic. I'm just copying some code over here from my write-up, and I'm always clicking on the wrong window. Here is a stacked area chart. This is using the plot area mark. So we have an area mark that and this is just a different data set here. This is the unemployment data that I showed last time, I think, where there is unemployment as percentage or as total. And of course, you don't want to stack percent, but you can stack total numbers. So this is now stacking so ignore this line here. This is just stacking the vertically, it stacks the number of unemployed, and the x-axis here is the date. And because we have a fill for industry here, we get this broken up into industries. So if interesting. Because it's not sorted, I guess. Not entirely sure why we're not getting just one area. It might have to do with the sorting of the values. I might have to sort the values first. But actually, I'm not going to do this right now. So you can imagine this, if there were no colors, then we would just get the whole thing filled with black. In this case, if we don't specify color, actually, let me try if I just do that. That's not what I expected. But so you could imagine this just being the whole thing being just one color, and then you would get the total value, which is what you see as sort of the outline of this. But because we broke it down by industry, this now gets stacked, and we get this kind of stacking of all these ribbons of the different industries being stacked up. And again, this is the same problem as before, that I can read the one on the bottom here. I could add this as a title. Industry. Then I could see what those are. And actually, this is kind of interesting because the outline helps you a little bit, but, well, not a whole lot though, because it's actually very difficult for us to read these kinds of things when they are at such a steep angle. Because what we do, there is a visual effect, and I forget the name of it right now, but there's an effect where we think we can read this as being just the width of this ribbon, this ribbon. But when the ribbon changes direction, especially when it does this, what we read is the width, kind of cross section of the ribbon, rather than the vertical height. So the way we look at this here is this. Sorry, here the tooltip is kind of in the way, but we look at the sort of like across, like we think we would read it like this, but we would need to read it vertically, because that's the correct. That's what is represented here, are the two values that are stacked on top of each other. And when this changes here, like here, it looks like the values are super tiny, but they're actually not that small, because the vertical distance, there's still quite a bit of distance between them, but it's just hard to see because the overall angle of this ribbon is so steep, and so that makes it hard to read this. And so partly for that reason, partly for aesthetic reasons, there are different ways of stacking these ribbons. And that is something you can switch. So you can change this to what's called silhouette here. This is also called the stream graph. There's the wiggle that I'm not exactly sure how this works, but it seems to magnify the changes, whereas the silhouette tries to smooth the changes out a little bit. And this has the advantage that it's a bit easier to read, because now you at least have two sides, and so there's less stacking happening. So you can see that none of these ribbons are extremely thin. Well, actually, some of them are, but as before. And then somebody asked about 100%, or like expanding the bars earlier in this example. And so this is basically the same idea, now expanding the ribbons to 100%. And so this is now going for every single value, every single day here in or month, I guess this is probably monthly data. I can take the values, add them all up, and then divide them all by the total, or divide them all by the total, and that way I get percent, and so that way I get these fractions here of the total value, rather than getting them stacked. It doesn't really solve. Well, it kind of solves the problem of the stacking. Well, not the stacking, but of the steeper gradients, because the stacking isn't as extreme, because here this all comes from the fact that the values are increasing. All of them are increasing at the same time, so you get this kind of mountain shape. But when you renormalize them for every single value, you don't see the total changing, but you would if, in case the relative fractions were to change, you would see that here. But you actually see that that doesn't actually change all that much, which of course you wouldn't expect for unemployment numbers. But so this is a way to show data in a bit of a different way. But area charts in general, I think, aren't all that useful for sort of like business data or the data that's very commonly used, because they have these problems of stacking, making it harder. And especially when it gets noisy, the data gets really hard to read. Just taking a look here at the discussion. Okay. Okay, and so before I get to the final part here, or the two final parts, a brief word about the assignment, since I mentioned earlier that I was going to talk about that, and then I forgot to get back to it. So the assignment, you will hear, we'll explain everything next week on Tuesday in the final class. And what we're working on right now is that there will probably be two different options. One will be, and that's because we realize that a lot of people are new to plot and observable, so we want to make this a little bit easier for folks who haven't done a lot of JavaScript, especially before. So there are going to be two options. One is to make charts, and you will get very specific instructions about what we're looking for. And we also have a data set that we're working on. And by we, I mean my colleague Paul Buffa, who has built a demo data set, essentially. And we're trying to get that into a more manageable form because it's very large. So we're trying to get it into a shape that is reasonably easy to work with, and to create some plots for. So that's one option. That's option A. And option B will be to look for charts on Observable and to look at the mappings, at the chart choices, at the things that we talked about here, and then do a bit of a write-up of what you think, how they work, and what else you could be doing for those. So this is a bit more of like a reflection versus creation of charts. So and again, the details we haven't written up, but we'll publish those next week before the class. So you will all see them, and I will explain what we're looking for in the assignment. And again, this is going to be due on April 4. So there will be, I hope, plenty of time, because you're going to get 2 weeks to work on this. So I think this should hopefully be sufficient. All right. Yeah, this is actually a good point here. But you really want this information or understanding, not data points. And these charts don't provide that. Yeah, I think that's a very good way of putting that. Okay, so, and I think I see some discussion. It's a bit hard to follow the discussion, sort of like side-eyeing that here. But there seems to be some discussion here about what people expect from people, what they show them, and yeah, I'm gonna not comment on that because I have opinions, and I've done some research on this actually, and I see that a lot of people essentially show the charts that they create for exploration in presentations. Anyway, so I'm just gonna copy over a little bit of code here to quickly show you something, which is smoothing. So I've talked about, again, transformations here, and how you go from some values to something that is a bit more useful to show to the point that I just highlighted there. That maybe you want to show data points, or you want to give people a sense of the data, and that can actually involve things like smoothing. So here is a sort of a demo here of that. I will just hide this and then zoom back in. So this example here, let's ignore the top part here. This is a chart of Apple stock price data, and it just uses the line here to draw this line, and we're drawing the closing price on the vertical axis, and the horizontal axis here is the date. But we've also added a function here called the window y function. And window functions, the way those work is they take a part of the data. So if I go back here, sorry about the scrolling, but if I go back to my table, we'll just use this one even though it's not very large, but you can imagine passing in a number of these, let's say 3 of them. So we take the first 3 and we compute something for those first 3. This is actually a bad example because this is not continuous. But the idea would be that if I have data that where I have a continuous value, actually, let's do this with the Apple data down here. Oops, come on. Past all the other charts. So Apple data. No, I'm looking for a table. My Apple data. But here I have the same data you're seeing in this chart, right? So this is we have dates, and then we have, I think it's the closing price. Yeah, so it's the close price. So if you just look at the close column here and the date, everything else we just ignore. And now I can go through this, and I'm assuming that this is in order of the dates here. I'm going to take the first, let's say, 3 values, and I'm going to look at these 3 closing values, and I'm going to compute the mean value of those. And then I'm going to shift down 1. I'm going to start the second row, take the next 3 values, next 3 rows, and take my closing prices again, compute the mean, and then do the same thing starting here from row 3, 4, 5 here, and do the same thing again. And so that way I'm computing, I'm looking at a window that consists of these 3 rows, and it slides across my data. And I could make the window bigger. I could have 10 values or 12 values or whatever, and have a larger window, but the window always slides across all of my records. And for each time I can apply the window, every time I move it down, so it doesn't skip over the values, it shifts 1 down, and then it's the same size of window again applied here. I compute a value. And so usually, very often, it's the mean value. And I can do this here. So this is the window. That's why it's called the window function, because you have this window on the data that slides through this table, essentially, the data set. And I can tell it what to do and how many and what the window size is. So in this case, I'm computing the mean, and I can change the window size. And as you can see, that smooths out these values. And again, the question is, what are you after? Do you want to see every single value here? Then you don't smooth. But if you want to see more sort of high-level changes without all the noise, then you smooth more. And so I can change that back and forth here. And I can also change how I'm doing this. So I could use the mean. I could also use the median. And then it looks a little bit shaggier because the median is is an actual value from the record. So this has a bit more variability. I could use the min value every day or every window. I could use the max. And again, if you get this kind of because these stay more constant over time. So the min max, I can also do the sum, which doesn't make a whole lot of sense here. Or I could do a ratio, which also makes no sense for this particular data set. But you can imagine doing and ratio just basically re-normalizes the values to the total within the window. And so the way this is specified here is that there are these 2 variables or these 2 fields called k for the window size, and reduce is the method that we use for reducing the values, so for computing the value within the window. And so this is another way of doing transformations. All right, and I'm at time essentially. So I'm going to just grab one more question. I'm going to basically just see, I can't answer this right now, but I will try to next time. So how much time do you think each part of the assignment will take as a JavaScript newbie? So I think our goal is to go for a small number of hours, 2 or 3 hours. We'll have to talk about this a little bit, and that's a good question that I'm going to try and address next time. So if I don't next time, please remind me. And with that, I think we are at time. I'm going to not go over this time, but I will just say thanks for watching, and thanks for asking questions, and please keep them coming also on the Slack channel. And I will see you again one last time on Tuesday. Thanks, Ian. Thanks, and see you.